Welcome back to the Nano Cruising Podcast. I'm your host, Stefan Marceau. This is the podcast where we talk about dinghy cruising, trailer sailing, and sometimes DIY, building your own boat. In that vein, we have Sean Petterson, who is the CEO and co-founder of SuperSede. SuperSede is an alternative to marine plywood, so let's dive into that. So today we're meeting Sean Petterson. He's the CEO, co-founder of SuperSede. SuperSede is a company that's redefining what's possible in marine construction, and we'll go over that. Probably the first place to start is tell me a little bit about you, Sean, and maybe your development before we get into the details with where you came from and what made you interested in this marine specific board alternative to plywood.
Yeah, sounds good. Thank you for having me. So like you said, I grew up on Long Island. I grew up working construction. My dad passed away on the job, which then sort of inspired my entrepreneurial career going forward. But he had a construction firm, so I used to work that. And when I couldn't anymore, I had one, and it was my only job I've ever had. I was working as a dock master at the local marina.
Nice.
So basically started there, just learning about boats and bringing them in, and then quickly learned that there's a lot of good deals on the dock, and I started flipping boats right there. Learned how to build them, fix them, and that's where I really cut my teeth in being all around the water. But fast forward, I go to college. I start a company that created all sorts of things to keep people safe on the job. And in parallel, I met up with my two co-founders who had started a company. They actually manufactured jet skis out of a thermoform material.
Okay.
We both sold our companies and came together and said, how can we make a better plywood? And as we got into the market, it became quite obvious how important that need is in boating. And so we went down to IBEX last year down in Tampa, Florida, and launched the company. And it was a great success in launching in the marine world. So Here we are. We're about 3 years into this, and now we're working with some of the biggest brands in the United States and making some boats better.
Wow. So tell me about this SuperSede Marine Board, what it is, and as an alternative to marine plywood. We know there's other alternatives, of course, but tell me how this came about and how it is as an alternative to plywood, or even plywood and fiberglass and so on. So
the idea started with Jordan and Shane just sitting around thinking how they can make a better plywood. When we realized that we could make it out of recycled plastics.
Oh wow!
And then
I didn't realize.
And then you look at it's made out of recycled plastic.
Wow!
And the idea there is that as far as lumber goes, we sell and use and consume a lot of it here in North America for construction generally, but specifically in boat building around the world. And we use a lot of it, which means we can displace a lot of recycled plastics from entering dumps and then entering our oceans. And I think that was the biggest driver for me was I spend a lot of time diving, and I spend a lot of time diving in exotic locations that are fairly remote, and somehow you still see a Pringles cap or a bag of chips floating by you when you're sitting at a beautiful reef, And so our mission is to really displace as many pieces of plastic from entering our waterways, and also from preventing as many trees from getting cut down.
Right.
Not the easiest challenge, right? Plastic is fairly dense, and when you're using recycled plastics,
it's probably
all kinds of
composition, right? So
and you don't really have the they don't have the best name for themselves, right? In terms of the strength that's associated with using recycled plastics. So we spent a great deal of time engineering formulations that can take a pretty wide spread of plastics, and reformulate them to meet the strength specs.
Right.
And that took a couple of different forms. So first was going through construction certification boards, right? So when you look at what's available on the market today, it passes certain marine standards in certain environments, like the British Building Standard.
Okay.
But the testing that is involved in developing new materials isn't really all that obvious, or at least not that available. So we said, let's just try to build it against the toughest spec, which is basically hurricane rated roof sheathing. Wow. And we passed those with flying colors, and developed some new criterions that set a higher bar. And we were able to achieve that, one, through material science work, so redeveloping some of those formulations I talked about.
Right.
And then also the design of the board itself. So the board is a semi-hollow profile, and we leveraged a little bit of AI to actually tell us where we should put some of that plastic and where we shouldn't, and came up with this sort of corrugated structure. Mm-hmm. That allowed us to not only achieve the weight that we're looking for, which is comparable to marine plywood, but it creates like an I-beam. So it's incredibly strong.
So because this is an audio release, it looks to me, you showed it on the screen, so it looks to me like a bigger version of cardboard, except it's not cardboard, right? It's got that's right. Okay.
Yeah, very, very similar to that. And that you're displacing the load, you're getting cross-dimensional thickness, and it's got very high compression strength.
Right. I only know, roughly in the old days, there was something called DuraCore. That was an alternative, and so on. You ever heard of that? DuraCore, I think it was called. Core Deck?
There are so many.
There's so many. Okay. Right.
There's so many. And I think that's what was really the
and it's not eco-friendly, definitely. Yeah.
No, it's not. It's definitely not. And both of those topics, right? There's a whole bunch of alternatives on the market to marine plywood, and there are a really wide spread of price points, and a really wide spread of performance points. And so what you get is all these really individual adaptations that, quite frankly, make the process pretty complicated. And a lot of that's complicated because of what I said, that the data is not necessarily readily available. The standards aren't necessarily readily available. And so we sort of took the approach of, can we make the Model T of marine plywood? And we're really marine sheathing.
Really?
Meaning that it'll work for a multitude of applications if we make it strong enough. And we make it the right weight, but more importantly, we make it at the right cost. And so that's where we're really seeing an opportunity, is that if you look at, marine plywood, there's a couple of, brand names in the OEM space. Then there's a couple of species type in the consumer space that you can choose based on your weight or your strength requirements. Right.
Yeah.
And so the price points can go from, $100 at the bottom end, $125 MSRP for a marine ply 3/4 inch 4x8 sheet, right?
Yeah.
And then it could go all the way up to $500, depending on what you're looking at. And there are serious diminishing returns as you get higher in terms of the price point. And a lot of that is because of the specialization. It becomes difficult for them to manufacture, right? And having small SKUs. So we saw there's a real great opportunity to make something that's easy to drop in replacement if you can make the strength requirements. And so the requirements were not just strength. You have to be able to laminate to it.
Right.
It's got to have really good fastener retention. So ours has about 1.3 times the fastener retention of plywood, which is the best as of right now. So we're a little bit better than what's the best on the market. And when it comes to just overall ease of use, there's no special tools. It's not going to require different routing bits or different fastener types. It really is a drop-in replacement for what the status quo is, but we're doing it at the cost of that status quo, which has allowed us to really make some headway as a new company in this market.
I guess there's the same thing. You must have different thickness and so on for different application, right?
Yep. 1/2 inch, 5/8, and 3/4 inch,
Okay.
is what we've got now.
Okay.
We add, we do a special process in our line that makes it adherable. So we'll have a dine rating of about 50. So you need about 43 for things to stick to it. Ours is about 50 when we deliver it. When you order that on as an additional additive. And, for us, what we're really excited about is the guys building it, right? So we service a lot of OEMs, and we go in there, and if they're using some of the more expensive alternatives, there's a lot of different gluing operations. There's a lot of fiberglass. There's a lot of chopping. Certainly a lot of waste, right? And that just goes right to the landfill. Ours is all fully recyclable. So when we take the offcuts back from the customer,
right,
at the end of the day, they fill up a Gaylord, they put it on a truck, they ship it back to us, we weigh it, and we give them a discount on their next order.
Oh, wow.
So they're getting zero waste.
Wow.
It's really clean.
Mm-hmm.
And then also when you are working with the traditional marine plywood, they're loaded with CCAs, they're loaded with formaldehydes, all types of toxic stuff.
Yeah.
And when you're sanding it, when you're cutting it, you're breathing it in. If you're wearing a respirator, you're still sweating, and all that stuff all that sawdust is landing on your skin, and you're soaking it up. And ours is, it's harmless, it's clean, it's recyclable, and it kind of chips off versus making sawdust, so it's not slippery.
Okay.
Easy to clean up,
Right. Do people cut it, and can they cut it and shape it, or how does, and what's the gluing process for that?
So cutting is the same. Routing is the same. We have folks shaping it in terms of like sanding, beveled edges. Stands great, stands really smooth. The gluing process, most glues work with it. There are a few that we'll recommend in our process, and the truth is it's typically less expensive than what's being used.
So what do you recommend for glues?
Depends on the operation,
okay.
Right? So if you're doing floor, if you're going to glue a carpet to it, we'll recommend something that is a lot of water-based glues are still used. If we're using a water-based, we'll recommend one with a little bit less water in it.
Right.
Because if you're putting it on wood, the wood's basically sucking up the water, right? And we don't have that. This is completely 100% waterproof.
But I'm thinking in boat building, for example, joining two panels or something like
Yeah, if you're doing,
So what do you do? Use typical fiberglass strip, or is that what you do? If you're joining
if you're joining two panels, we glue it right on the edges.
Oh, really?
That's typically what we do. Yeah, and the nice thing is you can fasten this more, because the fastener, when it buries itself in, you're heating up the plastic, so it creates a seal. So it's
wow.
It's fairly watertight as it is. And then if you want to back seal that, we would just we use 4200. That seems to stick. It's a pretty common one that's used in terms of a silicone sealant.
Okay.
And I think that's a big differentiator that we bring to the table as well is, when you're looking at all these substrates, everyone has the intent to glass them back in. Particularly marine plywood, right?
Right.
That's what makes it waterproof. Ours is waterproof, you don't need to, if there's applications, you don't need to do that. This can be exposed to the sun, can be exposed to the water,
wow.
And you don't have to worry about it.
Wow. That's probably a lot faster to build with that.
Yeah. So we're saving a lot of steps, right? That's the plan. We really want to make this easy to install.
Wow. Can it be used the same way in stitch and glue construction for boats? Is that what you do, or?
Not super familiar. What do you mean stitch and glue?
So a lot of small boat building, they instead of building a farm like in the old days, they basically put the panels together. They cut the panels, and they kind of saw, it's like sewing them, right? And then they glass it, then they put an epoxy filler to connect it, and so on. So Just trying to
Yeah.
how do you build a boat with that, where it connects and all that, right? So
Yeah, definitely. So, this is a new one, right? So we haven't gotten into the smaller hobby builds, and we
okay.
also are just exploring with how to bend it, right? This stuff is super stiff.
Okay.
And so in order to get a radius bend, we've been kerfing it. And what's really nice about these triangles is that they almost provide a guide. So if you can run your saw in between these triangles,
Right.
it bends in a really, really nice radius.
Right.
The next thing we're testing, which we haven't done yet, is doing drape forming. So finding a way to heat it, bring it up to temp, and then put it over a mold and get it to drape to the form. So I haven't gotten there yet, but those are things we're really excited to test. I will say, as far as stitching glue goes, if we can find a nice way to bend it, or if we're using a planar surface, and the material welds, so it's really nice. So you can use standard plastic welding techniques, and the joints are incredibly strong. So if there's a way to jig it up, you actually won't need to do any glass, right? If you can weld those seams together, you can build something that stands on its own, and there's no secondary, processes.
Wow. Are you looking for some people to try this out in small boat
Yeah,
building?
yeah.
I think
Please,
you
anyway.
may get a few emails from that to
Perfect.
experiment with that, right? So. What about the maintenance long term and in the wet environment? I'm guessing it's a lot less, but tell me about the maintenance and the durability and so on of that.
Yeah. So what's nice about what we do is, by using the recycled plastics, you want to get a uniform color. And so what we do is we add a little bit of what's called carbon black. And so that's a very small amount of material we put in there it basically just dyes everything black. And so that gets us a uniform color. So it's not, the color of, half a Gatorade bottle and half a milk carton, right?
Yeah.
So to get the uniform color, we do the carbon black, and carbon black is inherently one of the most UV stable materials out there.
Oh, wow.
So this has a great UV protectant on it, embedded all the way through the entire core of the material. And additionally, it being waterproof, there's not really much you need to do. It's as of right now, we do a lot of life cycle testing, and we've got a performance envelope that stretches over 30 years. And, we don't have any recommendations for maintenance because we just don't really see any that are required.
Okay. And I guess you probably have some recommendation for paint and so if somebody who doesn't want a black boat.
Yeah. So in the meantime, you can get in any color you want as long as it's black.
Right.
But what we're doing is two things. So one, we have an adhesion promoter that we recommend. And if you're going to paint it, you can put the adhesion promoter on it, and then you can get a whole lot of paints, a pretty wide spectrum.
Okay.
I don't have the exact spec of the right paints, but I've tested just about everything in our lab, and so far it all sticks. The next thing we're doing is this is a multi-color material. So we do a dual extrusion where we're actually able to produce a different color on the top than we are in the core.
Right. So it's the same.
And so this is there's
a color in the top and a different color in the core. Right.
Yeah. So we'll be offering some different ones for that. We won't be offering that at a consumer level just yet because we don't know how many colors to stock, and we're trying to figure all that out. But that will be on the long run.
Right.
In between that, we have a laminator press coming in. So we'll be able to laminate, and at least show others how to laminate different types of veneers on the outside, whether that be, for color, for traction, for, aesthetics, for, if you want to put wood on there, so that you have, something that looks like wood, is wood on the outside, but has all the benefits of being a, completely 100% waterproof panel from SuperSede.
Wow. Nice. So what's the ideal use case for this plywood? I guess you've got people building boats already with this?
Yeah, we've got people building boats and RVs, and it's the biggest use case right now is the flooring, right?
Okay.
So areas where you're going to get the most impact, where you're going to get the most rot, where you're going to, where you need a wide span. We're seeing, that's been our entry into the market right now. It's just it's just the perfect material for that.
Yeah.
Beyond that, we're getting into obviously some walls. We're doing a lot of steets. We're doing a lot of, cabinet doors. We're doing access panels. And so it's branching out from there.
Mm-hmm.
But the ideal use case, at least to prove, what this material's worth, it's in the flooring, right? You're beating it up. You're dropping anchors on it. You're hosing it down. And this has been, in some cases, we're obviously replacing wood, but we're replacing the more expensive laminated panels. In some cases, we're replacing, aluminum floors. We're replacing, layups and gel coated floors. And it's saving the manufacturer cost. It's saving the builder cost. But it's at the end, it's just created a better product for what you're doing. Next for us on the testing horizon is we're doing our first transom layup.
Okay.
And what's cool about that is this has a incredibly high compression strength. So you do not have to worry about, you'll snap the bolt basically before you start compressing our sheets. So we're doing that, and we're doing that in a standard layup. And then we're also doing that in a transom where you're not glassing it at all. So you have an aluminum loop, you push this in, and you bolt your motor to it, and you're off to the races. So that's next on the horizon for us to, eliminate the need for a very complex transom setup.
Yeah, if you can avoid all the glassing, that saves so much time and work, and maybe some sanding, but maybe not that much from what I've seen, right?
Yeah. I think, it's always frustrating when you've got spider cracks in your gel coat on the back of your transom and things like that. And, hopefully we can eliminate a lot of that.
Right. Any, the DIY success stories you've seen, some good stories using it and boats?
We had a person with a pontoon boat. They bought a new pontoon boat, and the first day in, they fell through the floor. They were able to strip the boat down and put our stuff in, and in a matter of days, because nothing changes in the process. Right. So those use cases are really, those have been great. And then some others, we have some really rugged aluminum fishing boats out there.
I can imagine. That's what I was thinking before. That sounds like it's really strong and be great for, like a big fishing boat, definitely.
Yeah. So, Thunderjet, their aluminum fishing boats are being built with these in some of their floors. And, for us, what a great use case, right? Rugged boat built to work. And we're right in there with it.
That's great. Any limitations to this?
The only limitation is people understanding how stiff it is. We want to make the Model T, but, it's not like a Gaboon, right? Where you can bend it a whole lot. We are, it's a stiff boat. So it's a stiff board. We're still, like I said, in those exploration phases around best practices to get a radius on it. Yeah. But those are really the only limitations, right? It's just trying to figure out, how to get big bends. But beyond that, any planar surfaces is great. If you're doing like a vacuum bag setup and laying in, stringers, we recommend that you tape off the edges, because you don't want to get your resin to suck up into the voids. But so far, that is, I wouldn't necessarily say we have limitations. There are just new adaptations to the process that, when you're starting to combine fiberglass, we want to learn about. But our take is let's reduce the amount of fiberglass you're using.
Yeah, I'd love to I hate fiberglass. I'd love to get rid of it totally. It's just,
exactly.
I'm somewhat allergic of it, so I just hate
I think we all are.
Any plans for, I don't know if there's plans for developing kits, plans, or so just things like that?
You mentioned that, and it really got our gears turning. So we have a CNC machine set up here. We already kit parts for customers today, in terms of like those seat backs and things like that.
Yeah.
So I'm going to look into some of these,
because I have some ideas. There's a lot of nice small boats that they're all CNC based. Basically, you buy the plans in CNC. That might be a really good use of that too, to put to cut that and put that together. So that might be a service too. Yeah,
you sent over one of the Oz racers, and those are all planar surfaces, right?
Yeah,
this seems to me like it'd be
ideal. Yeah,
it's our gears are turning. This might be the Saturday project. So we'll see. More to come.
Yeah, if you need, I'd love to get involved with that, or I'm sure somebody would. It sounds like a great tryout of this technology. So
I would love really that, well. And then to plastic weld it all together, use zero fiberglass. I think that would be one that that idea is going to you with a case of beer. So.
I know you've covered a little bit. So what's next for SuperSede and the marine market? You've covered some of it, but
like I said, it's getting our hands dirty on some of these other more, I guess I would say, technical or craftsman oriented, right? We focused on big production, right? So we're going to OEMs where we can make this a drop-in replacement, and so we're working with marine OEM level adhesives and fasteners and processes and, doing this stuff for high volume.
Right.
Our next endeavor is to continue to find ways to present best practices and do that through experimentation. So finding ways to curve fit, finding ways to drape form it, finding ways to expand our use cases outside of, the flat planar surfaces. And then it is in the materiality. So experimenting with lightweighting, making certain adaptations that are a little bit more bendable and flexible, because what's really nice about the materials, even if you make it more flexible, you're still going to have incredible impact strength, right? So this is going to be really durable. And we are going to just continue to push the boundaries on that, as well as material selections, colors, and, make an offering around what these laminated surfaces are.
Right.
Because, that would be really great to have something that truly has the beauty of wood on the outside, but on the inside has all of our technology and recyclability built into it.
Wow, that's such great plans. I'm going to keep an eye on you, definitely. So anything else you want to cover that we haven't mentioned, or things you were thinking about we need to tell our listeners?
I think that the whole thing that we're most excited about is the two benefits we bring to the table. And I think one benefit is the performance, and the other benefit is the actual impact environmentally. Mm-hmm. And I think I think the unlock for that is just getting folks more comfortable with this idea that there's a new material in town, right? And I think for us being able to come up with new ideas, just like you said, to find new ways to implement it means that we'll have a new area that we can displace more plastic. And I think that's what we're looking for. And adversely displace some of the other harmful materials. You have to do what you have to do to build a boat. And we've been doing this for years, but now there's a step change is what we're hoping to present, where we can eliminate some of the things in the process and take the mindset out of, you don't need to fiberglass everything if the thing underneath it is perfectly strong and perfectly waterproof.
Correct.
Right?
Correct.
So, we're looking for ways to kind of get folks to think outside of the box. And if we're saving steps and we're saving material, we're saving weight, we're saving costs, and we're saving waste, right? And I think that's our end goal is to really drive that idea home.
Thank you so much for spending time and introducing us to this. I think there will be a lot of interest. You may get people going to, I'll put the link to your website and information, and you may get interested in different small boat builders, and they have some ideas and see how they could be applied. So really appreciate the time you spent with us.
Oh, same here. Yeah, SuperSede.build is where you can find us. So I'm going to look at more of these. I think my weekend's now spent looking at these boat kits. So.
Exactly. So, Nano Cruisers, if you have a project in mind that could fit using this material, I would encourage you to contact Sean. I think this would be really neat, kind of curious of what it could do. So check out supersede.build. So thank you for my listeners for sending suggestions, as this podcast is really built with a lot of your input. So thank you for that. In closing, join our Facebook group, Nano Cruising. If you want to be kept abreast, check out nanocruising.com and join our mailing list. And last but not least, as usual, seize your own adventure.